Hello, good morning. Welcome back to Chemistry with Ms. Hernandez. Today we're going to be covering section 7.11, binary molecular compounds. And remember, this lecture is exactly what is in the packet. All right, so let's continue. All right, so why do so many relatives and royalty share the same name? Same name, right? There's a lot, especially in the Hispanic culture, we have a tendency to use the same name when it comes to family members, to a growing family, right? Who's gonna help me read?
Some families name a son usually the firstborn after his father, so it is somewhat common to find John Smith Jr. named after John Smith, the father. A few families may take it further and name the grandson John Smith the third. Countries with long histories of royalty take the naming even further. One line of kings named Harry goes up to Henry VIII, not the nicest guy in the world. He had 6 wives, and 2 of them came to intimately, and the use of numbering for names adds clarity to a system. We always know which Henry we are talking about.
Thank you, Alexia. So Henry VIII, that means there was 7 other Henrys before him, right? The original Henry, Henry II, Henry III, all the way to 8. He was a very, not a very nice, like they say, he wasn't a very nice guy. He would accuse his wives of infidelity, meaning that they were cheating on him. So the punishment he would always tell, or he would always, the punishment he would always give these wives was decapitation. He was famous for decapitating his wife. Okay, so I know. So it says here at least 2 of them came to that untimely death. All right. So the reason why he's known as Henry VIII is because there was other Henrys before him. In the naming and formula writing system, we do use a numbering system to identify the names of these compounds, okay? And that's what we're going to be talking about today. And I might be going a little, you guys might notice I'm going a little faster than usual because this is a very long lecture and we don't have a lot of time for it. Okay, we only have today. So I'm going to try and go as quickly as I can so that we can cover everything that you need in order to understand how to name these compounds properly. All right, inorganic chemical compounds can be broadly classified into 2 groups: ionic compounds and molecular compounds. Ionic is what we started discussing last week. This week or today is molecular compounds. Okay, so remember that because you're going to be needing that. The structure of all ionic compounds is an extended 3-dimensional array of alternating positive and negative ions. Since ionic compounds do not take the form of individual molecules, they are represented by empirical formulas. So that's what we were doing last week. We will now begin to examine formulas and nomenclature for molecular compounds. And you got to remember, when we were doing last week, ionic compounds, we're talking about cations giving up electrons to anions, as they show here. For molecular, today, look at this. You got some buddies, right? You got buddy purple, buddy green. Buddy green is sharing his 1 green electron with his buddy in purple, and his buddy in purple is sharing his 1 purple electron with his buddy in green, okay? So we talked about ionic. Now we're talking about covalent. Okay, keep that in mind. Ionic, covalent. Not covalent, molecular. They call it molecular. It's just almost the same thing, but they just call it what it is. It is molecular. Ionic was last week. This week, molecular. All right, type it in. Type in your answer. Compounds can be classified into what 2 groups? What 2 groups? What were the type of compounds we talked about last week, and what is the type of compound we're talking about today? Please type in your response. Type it in. Type it in. No responses. What type of compounds are we dealing with today? It says it right here in the title for today's topic. Well, what's the title for today's topic? That is one type of compound. What was the type of compound we talked about last week that has cations and anions? 2 people are in Pear Deck. Where are the rest of you? Do I need to put the link? Let me put the link again. Not good, guys. I need more people in Pear Deck. All right. Molecules. That's one type. Molecular, actually, right? Molecular. What was the type of compound we talked about last week? Where you have cations and anions. Anybody recall? What kind of compounds did we talk about last week? We're talking about molecular today. Last week we talked all about ionic. Thank you, Oscar. Ionic and molecular. All right, so what is a molecular compound? Molecular compounds are inorganic compounds that take the form of discrete molecules. So you're gonna see these molecules. Examples include familiar substances like water and carbon dioxide. These compounds are very different from ionic compounds like sodium chloride. Ionic compounds are formed when metal atoms lose one or more of their electrons to nonmetals. Okay, so ionics lose metal atoms lose to nonmetals. The resulting cations and anions are electrostatically attracted, right? You end up with a positive, you end up with a negative, and there's a pull for them to come together. That is how ionic compounds form. Larger molecules can have many, many bonds that serve to keep that molecule together. In a large sample of a given molecular compound, all of the individual molecules are identical. So what holds atoms of a molecule together? Rather than forming ions, the atoms of molecules share their valence electrons, right? Not those inner electrons, those outer electrons. Those valence electrons are shared in such a way that a bond forms between the pairs of atoms. In carbon dioxide molecule, there are 2 of these bonds, each occurring between carbon and oxygen. So you have a bond between the valence electrons of a carbon and oxygen here, and then a second bond between carbon and the oxygen on the right. Okay. Just a quick review about molecular formulas. Recall that molecular formulas show the actual amount of each element in that molecule. Okay. For ionic, we weren't. We were working with empirical formulas. We would reduce those subscripts as much as possible. So in reality, there might be more of those elements than there actually is in the formula. Okay. The molecule of octane, a component of gasoline. Octane is one of those ingredients for gas. Octane contains 8 atoms of carbon, 18 atoms of hydrogen. That's a very large molecule. The formula C8H18. Nitrogen dioxide, a reddish brown toxic gas that is a prominent air pollutant, and it's made by internal combustion engines, kind of like vehicles, right? Vehicles, internal combustion engines. Naming binary molecular compounds. So this is the beginning of it. We're going to continue in the next couple of slides. A binary molecular compound is a molecular compound composed of 2 elements. The elements that combine to form binary molecular compounds are both nonmetals. So last week we were talking about ionic. Ionic has a metal with a nonmetal. Today, moleculars is always nonmetal plus another nonmetal. Therefore, binary molecules are different because ionic charges cannot be used to name or to write formulas. You cannot use the same steps that we used last week for ionic. It's going to be different. Another difference is that the two nonmetal atoms will frequently combine with one another in a variety of ways. Consider the elements nitrogen and oxygen. They combine to make several compounds, including NO, NO2O, NO2, sorry, and then N2O. They all can't be called nitrogen oxide. No, we have to distinguish between the two. How would someone know which one you're talking about? Each of the three compounds has a very different properties and reactivity. A system to distinguish between compounds such as these is necessary. Okay, so just a reminder, ionic, metal, nonmetal, covalent, which is what we have for molecular, is nonmetal plus another nonmetal. All right, second Pear Deck question. Your second Pear Deck question. What are molecular compounds made up of? Molecular compounds are composed of A, metal plus a nonmetal, or B, nonmetal plus another nonmetal. What would you say, guys? A, metal plus nonmetal, or B, a nonmetal plus another nonmetal? What is your answer for this one? What do you think? Answer A or answer B? What are molecular compounds made from? Composed of. You use the word composed of, but it's just a fancy word for what they're made of. A or B? What do you think, Melissa, Arlette, Jose? What do you think, Melissa? A or B? What would be the correct answer for this one? What are molecular compounds composed of? A nonmetal and a metal plus a nonmetal, or B, metal plus nonmetal? What is it? No responses. Oscar, what about you? Alexia? Mario, what do you think? Molecular compounds, molecules, are composed of what type of atoms, what type of elements? What do you think? A or B? A metal plus a nonmetal, or B, nonmetal plus another nonmetal? Mario says A. Mario says A. Is everybody going to agree with Mario or disagree? Melissa, Arlette, what do you think? No, don't start barking. Be quiet. Go back to sleep. Is Mario the only person listening? You agree with Mario. Okay. So that's 2 votes for metal plus non-metal. All right. You chose A too? All right. Let's see. Let's go back. Naming binary molecular compounds. Molecular compound is composed of, it says here, the elements that combine to form binary molecular compounds are both what? Are both nonmetals. Are both nonmetals. The answer was B. A nonmetal plus another nonmetal. Careful, guys. We're not listening. Numerical prefixes. Numerical prefixes are used in names for binary molecular compounds to identify the number of atoms of each element. So those subscripts at the bottom, they're going to change to these prefixes that you see here. Excuse me so much. So if you have a subscript of 1, you're going to use mono. A subscript, if you see 2, di. If your subscript is 3, tri. If your subscript is 4, tetra. If your subscript is 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10, deca. Okay? Those are the prefixes for the subscripts. Those little numbers at the bottom, they're going to change when you name it into these prefixes, okay? Draw a line and match each number to its prefix. So if you have a subscript of 1, what is the proper prefix? If you have a subscript of 2, what is the proper prefix? Match them up. Go. Match them up. And I want to do this quickly. Come on, we cannot waste time. Which one is the one for 1, mono? What's the one for 2? So if I have 1, right? 1, according to the picture before, was mono. So I would draw a line from this 1 all the way to the very bottom. 2, di. Thank you, Melissa. Which one's 3? Tri. 4? Great job. Those of you who are trying to do it on Pear Deck. What is the prefix for 4? Tetra. What's the prefix for 5, 6, 7, all the way to 10? Keep going, Melissa. 4 tetra, 5 penta. Keep going. So far, so good. So far, so good. 6 hexa. 7 hepta. 8 octa. Very good, Mario. What about 9 and 10? Who can give me 9 and 10? I need only 9 and 10. 9 is nona. 10 deca. Very, very good. Let's see how they did. Excellent. I hope they matched these correctly. 1, mono. 2. Oh, yeah. If it would have been different colors, it might be a little bit easier. But for now, that's good. All right. Rules for naming. Let's just read it and then we'll discuss the examples, okay? Because it's confusing. Generally, the less electronegative element is written first in the formula. Okay, so the ones the furthest away from fluorine, right? Fluorine is the most electronegative element of all nonmetals. Generally, the less electronegative element is written first in the formula, though there are a few exceptions. Carbon is always first in a formula, and hydrogen is after. Nitrogen in a formula such as NH3. The order of common metals in non-binary compound formulas is carbon, phosphorus, nitrogen, hydrogen, sulfur, iodine, bromine, chlorine, oxygen, and fluorine. Okay. When naming, the appropriate prefix is used only if there is more than one element. So if you're talking about element number 1, you can use all the prefixes except 1. You can never put mon for the first element. Okay? If you're talking about element number 1, so in your examples, you're talking about nitrogen, sulfur, and chlorine, right? You can use all the prefixes except mon. Mono is not used. For the second element, you can use all of them. The only thing is change the ending to IDE, just like you were doing last week. The first element name does not change. The second one ends in IDE, okay? The appropriate prefix is used for the second element. if you have A or O at the end of your prefix. If you have an A or an O at the end of your prefix, drop it when the name of the element begins with a vowel. Everybody knows what a vowel is? A vowel is like A, E, I, O, or U. If your element that you're writing, that you're working with, if it starts with an A, E, I, O, U, E, I, O, U, right? A, E, I, O, U, drop the A or the O, and then just put the name of the element. For example, if you have 4 oxygens, you're supposed to use tetra, right? If you have 4, sorry. If you have O, I won't clear it. If you have O with a what? A 4, right? You got an O and a 4. You know that you're working with oxygen, but the rule says take this part away and add oxide. Okay, I did that. But since my prefix is supposed to be tetra, it ends in A, but this guy ends in O, this guy goes away, and all you write is TR, TETR, oxide. Sorry. Tetroxide. Okay? If you want to leave the A for today, I don't mind. Okay? I'm not going to take off points because you leave one little letter. Okay? But the correct way to write it is by taking off the A and just putting RO, oxide. Right? Okay? All right, so you have some examples. NO and N2O. Okay? So we have NO and N2O. Well, we know the elements. The elements are nitrogen and oxygen. Okay? Do I need a prefix for this guy, for the first element right here? Do I need a prefix for this guy? What's the name of N? We said was nitrogen. We cannot use mon, right? Because mon means 1. So I'm just going to write nitrogen. Let me get this thing closer. Now I can use mon for the second element. So I only have 1, right? So I'm going to put mon. Oh, not mon. Mon. And then oxygen changes to oxide. Now, I still have nitrogen for my first element. So, but what's the prefix? What's the number that I have here? What's the prefix that needs to go in front of nitrogen? What's the prefix for 2, Melissa, that you listed earlier? Didn't she write it earlier, guys? What's di, right? Di. So I'm going to write di nitrogen. And my first part is done. I added the prefix. I didn't change the name of the element. The first part is done. But how many do I have here? What's the prefix I need for that oxygen or oxide? What's the prefix for 1? What's the prefix for 1 according to the list? Mon, right? Mon oxide. Y ya se acabó. This is the proper name. This is the proper name. We're done. Okay. Next examples. S2Cl2. S2Cl2. What's the prefix I need for S before I start? What's my subscripts? right? Both of them are 2, so both of them are di, right? The prefix for 2 is di. What's the name of the element S? What's the name of the element S? Looking at the chat, what's the name of S? I know the prefix is di. What's the name of S according to the periodic table? Right here. Not silicon, that's Si. What's the name of S? Element 16, right here. Sulfur. Thank you, sir. So I'm going to put disulfur, right? Disulfur. Hey, America, I didn't even see you come in. Now, I got 2 chlorine, so I'm going to put di again. But chlorine. Take off the ending and add IDE. What's the new end? What's the name of this guy? Disulfur, di what? Dichloride. Okay, that would be the proper name for this guy. Disulfur dichloride. All right, let's see if you can do the last one. Cl2O7. Hold on. Cl2O7. Yes. Okay, first let's identify the prefixes for 2 and 7. We already identified for 2. It's up here. It's di. What's the prefix for the number 7? Hepta. Chlorine changes into dichlorine. And then heptaoxide. Very good. Perfect. Skip A, because we already did it. Skip A, but do B and C. Try it out. B and C. See if you guys can do it. Very similar to what you just did, right, Oscar? Except what prefix should you use for O? Isn't the first part the same as the last one that we did? There was 2 chlorines. We wrote dichlorine. Yeah, right? If I got Cl2O8, well, the first part it doesn't change, right? I know that 2 means di. I know the name of Cl is chlorine. So just like Oscar's giving us in the chat, it should stay as dichlorine. 8, the prefix for 8 is octo, right? Oxygen changes to oxide. Done. Dichlorine octooxide. Okay, one more. SO3. Oops, not a 2, a 3. What's the name of S according to the periodic table? What's the name of S? Oscar, Melissa, America, you put it earlier. What's the name of S? Sulfur. There's no prefix because there's a 1, right? So we're just going to write sulfur. Very good. And the prefix for 3 is tri, just like Oscar posted in the chat. So we're going to put tri, and then oxygen changes to oxide? The answer, what do you think? A little complicated, but not as complicated as what we were doing last week. Okay? Not as it's definitely easier, right, Oscar? Definitely easier. Okay? Let's watch a little bit. We'll watch a couple minutes. If it takes too long, I'm gonna cut it off at 12:55 because I want time and enough time to, like, it's a 10-minute presentation. We're just gonna watch a little bit. If it can start anytime soon. No commercials, no commercials, no commercials. Come on, no commercials.
Let's look at how to write names for compounds like these that are made of two nonmetals. The nonmetals are the elements to the right of the staircase on the periodic table. Now, compounds like these that are made of a nonmetal and another nonmetal, two nonmetals, are called covalent or molecular compounds.
Does it look very...
And that's because the elements that are in them are held together by covalent bonds, and they're held together in groups called molecules. Now, the way we name covalent or molecular compounds is different from how we name ionic compounds. Ionic compounds contain a metal and a nonmetal. The metals are the elements here on the periodic table, and I've written in some of the most common. Some examples of ionic compounds and of how we name them are things like calcium fluoride.
Let's see if I can go forward.
Okay, here's our first chemical formula, N2O3. It's made of two nonmetals. We're going to write a name for it following these.
Grammarly does more than catch errors. With Grammarly, you can find really good,
these steps. So, here's the first one. It says for the first element, start with the element name. When I'm talking about the first element, I'm talking about the order that these elements are in this chemical formula. So the first element here is nitrogen, N. So it says start with the element name. Okay, so I'm going to put nitrogen down. That's the element name here. Now for the second element, so that's this here, oxygen. For the second element, start with the IDE name. Now the IDE name is the version of the element name that ends in IDE. These are actually the same names that we'd use to name negative ions. So we've got oxygen here. We're going to use its IDE name, which is oxide. Okay? So we got nitrogen and we got oxide. Now, use prefixes to show how many atoms of each type there are. The prefixes, here's a list of them, are like these little tags that we put on the front of each name to tell us how many atoms of each type we have. So, N2, we got two nitrogens, which means that we want to use this prefix for two, di. So put that in front of the element name, dinitrogen. Now O3, which means that we have three oxygens. So I'm going to use the prefix tri here and write that in front of oxide. And so the name for this compound is dinitrogen trioxide. We put the element name here, we put the IDE name here, and then we use the prefixes to indicate how many atoms of each type we have. Let's look at a few.
All right, so I don't have time to look at the whole thing, guys. I'm sorry. Let's go back to the presentation. Let's finish up the summary. Molecular compounds are inorganic compounds that take the form of discrete molecules. Two atoms of these compounds are held together by covalent bonds. And number three, prefixes are used to indicate the number of atoms of an element that are in the compound. Okay? Your review questions. What are molecular compounds? How do they differ from ionic compounds? What holds the atoms of a molecule together? Are elements of molecular compounds metals or nonmetals? What is the prefix for the number of atoms of an element when there are four atoms? What is the prefix for the number of atoms of an element when there are 7 atoms? And then it asks you to name some examples, okay? All righty.